All right, y'all, welcome back. Meet me right here on page 532. Good news is we've already gotten started on this in all of our classes. All the 6th grade classes have already done at least the first 3 shapes. That's our good news. If you haven't, then pause this video and catch up and see if you can figure out where I got 4, where did 8 come from, and where did 12 come from. Good. Now that you're caught up, then you remember that 4 came from the perimeter. Perimeter is the distance around. We've already annotated it. We're looking for patterns here because we're mathematicians, and that's what we do. And we saw, oh, this has a perimeter of 4 because the distance around is 1, 2, 3, 4 units. This has a perimeter of 12 because the distance around is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units. That's where our perimeter came from. Good, we're all caught up. B, I asked you in class to draw just this shape, so that's why I'm asking you to cross out 3. I don't need you to sit and draw shape 4 and draw shape 5 and draw shape 6. You probably have already drawn just shape 4. If you haven't, then follow me. I see a pattern because I'm a mathematician. I notice that right here, each of these, if I do like this, they all match. But look what changes from shape 1 to shape 2 on the next row. Oh, they just added another. And then look what changes from shape 2 to shape 3 when I go to the next row. Oh, they just add a row, and to that row they added another square. So that means the next one would be add another row, and in that row there should be 4 squares. So if you drew this shape correctly, check and see. That means this one should look like shape 1. Then it should look like shape 2. Then I should see shape 3. And then here would be adding another row with 4 in the row. Here's your 4th shape. 1, 2, 3, and 4. Now we want to count the perimeter of shape 4. Now pause and think. Here's option 1. I could sit here and count 1, 2, 3, 4, 5, 6, or I can be a mathematician and look for a pattern. What do you notice with the perimeters of the 3 shapes I already have? Good. They are increasing by 4, counting by 4. 4, 8, 12, which means this has a perimeter of, you got it, 16. 16 would be the perimeter. Let's stop real quick and fix our answers. None of these answers are actually correct. The perimeter of this shape is not 4. It's 4 what? Good, that's right. 4 units. Let's label it. Not 8, but 8 units. 12 units, 16 units. See if you can tell yourself why it's not square units. When would it be square units? Think about what we talked about in class yesterday with the algebra tiles. Okay, so I don't need to draw shape 5. Let me just calculate the perimeter. 4, 8, 12, 16, 20 units. And shape 6 would have a perimeter of 20. Good. 24 units. I can see this pattern using these models, using these diagrams. I also need to be able to see this pattern using another piece of information. The other piece of information would be a table. Grab your highlighter and highlight the word table. As a mathematician, we've got to be able to take some data, take some pieces of information that we discover, and organize it. And this is one way we can do that, into a table. If I put this into a table, look what I see. I see 2 titles, the shape number and the perimeter. Well, I know that the shape number correlates to what shape it is up here. There are 6 of them, so I can go ahead and fill those in. Shape 1, 2, 3, 4, 5, and 6. This column says perimeter, the perimeter of each of these shapes. Well, if I look up there, I see that each of these shapes had a different perimeter. Shape 1 had a perimeter of 4 units. I don't have to put U because look, it's already labeled for me in the title. Shape 2 had 8 units, 12, 16, 20, and 24. This information in this table tells me the exact same information as those problems. This is just another way to organize it. Good. Turn the page. Let's keep it going. I'm going to, if I would take mine and lay it flat, like this. You're able to do that. Miss Leonard doesn't have the space to do it. But if I were you, take these 2 pages and lay them flat so you can see them both at the same time, and you won't have to keep flipping over like Miss Leonard's about to do. Okay, here we go. Number 3. Now that you have that table, we want to calculate the perimeter of the 7th shape using that table. 7th shape. Circle 7th shape. We found 6 shapes. What's the next shape going to look like? Pause this video and then figure out the answer. All right, let's see if you got your answer correct. If the 6th shape had an area of 24, here's how I can figure out the 7th shape. Here's option 1. There's 2 things you could do. There's actually multiple things you could do, but here's one of the things. You could have looked and said, okay, well, let's see. I notice a pattern because I'm a mathematician. I see that each time, each shape, its perimeter is really just adding 4 each time. This one's 4 greater than the previous one. This perimeter is 4 more than that perimeter. So I can keep following this pattern and apply that pattern to shape 7. That's an excellent pattern. If you found that, props to you. Very good job. So I can use this table and see, oh, so then the 7th shape will have a perimeter of, follow the pattern, add 4, its perimeter will be 28. Nice job. That is an excellent strategy. I love that you found that pattern. However, can you think of another pattern? Is there another way you could have figured out that the 7th shape would have a perimeter of 28? What other patterns do you see in this table? Good. I'm not going to say it because I'm sure you figured it out, but check this out. Now they're asking for, let me go ahead and fill in my answer. The answer I got was 28 units. Number 4, calculate the perimeter. You ready? The 20th shape. Oh my. Think about that pattern you just used. If I go back to this table, that means I got to keep going all the way down until I get to this number being a 20. I got to figure out what the perimeter would be. No, thank you. Because I'm a mathematician, I can find more than one pattern. I bet you've already found it. I bet you already used it. A pattern is great for the smaller values, but man, I probably should come up with another pattern to get to this large number here. If you found it, props. You also could have found this pattern. What's happening between my shape number and its perimeter? Can you see the pattern that's happening there? If you do, excellent job. It's being multiplied by 4. 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. You get the idea. And that's how I know, hey, if I could have just done 7 times 4 is 28, then I could just do, here you go, 20 times 4 gives you, good, there's your answer. If you can't do it in your head, realize that you can do it in your head. 2 times 4 is 8, which means 20 times 4 will be 80. Good job. Fill that in. So the perimeter would be 80 units. Surprise, surprise, look what I want you to do. Write an algebraic expression. Algebraic tells you that it's going to have variables. An expression tells you that it will not have an equal sign. No equal sign. I probably shouldn't have done that. That technically means not equal. But you get the idea. Write an expression that describes the relationship between a number, shape number, and the perimeter. Look at this table. How could I have determined the perimeter of any shape number? Shape number 42, shape number 47, shape number 35. What would you tell me to do to that shape number in order to get its perimeter? Pause and think. That's right. You would have simply said, take that shape number and multiply that shape number times 4. That is an algebraic expression. Let's simplify it. You would simply say, take the shape number, and that's going to be whatever number that you choose it to be. Since that number can keep changing, I need to give it a variable. I'm going to choose this variable, s. S is going to represent the shape number. I just did this step. Put a 2. That's step 2. I defined my variable. I haven't yet written an algebraic expression. Put a 1. Let's do step 1. I would take the shape number, s, and I would multiply that shape number by 4, which means 4 times s, 4s. There's my algebraic expression. If your pattern continues, what shape has a perimeter of 500 units? Well, look at what you just said. In order to get that perimeter, you would take your shape number and multiply it by 4. Well, now I'm asking you this. When would that give me 500? Now it's an equation. I'm really trying to say, what number would this have to be in order for 4 times that number to equal 500? How would you figure that out? You got it. You would divide. You would take 500 and divide it by 4. When you do that, you get 125, which means S, the shape number, would be shape 125. How do I know that? Because I can check. 125 multiplied by 4 equals 500. Turn the page very quickly. You just saw how to take information and put it into a table. Now let's take that table. You wrote it as an expression. Take your expression, and last but not least, how would that look on a graph? Make sure you're on the right page. Here's the page I'm on. 5, 3, 4. Use your table from question 2 to plot the points on the, highlight the word, graph. Here we go. Good news, they've already done most of this graph for me. Look, they already did my scale. They already labeled my x-axis. They labeled my y-axis. All I have to do is fill it in. Here I go. If you're able to, take this page and lay it flat beside this page, because these are the numbers I'm going to use to fill in this graph. Miss Leonard can't do that, so I'm going to have to do some flipping back and forth. I will race you. See if you can take these numbers and put them into the graph faster than Miss Leonard. Ready? Go. Did you do it? Did you see the pattern? 1 had a perimeter of 4, 2 had a perimeter of 8, 3 had a perimeter of 12. You should see the pattern that it creates. Ooh, what do you notice? That these points actually form. Okay, let's go back to the first semester for a minute. Would it make sense to connect the points? Let's see if you remember what that means. If you can connect those points, then let's annotate that. That means fraction values would make sense. You're telling me that it would make sense to say that I could put a little point right here. That shape 1/2 would have a perimeter of something. Well, would that make sense to have shape 4.5? Would it make sense to have a shape 3.5, 3.25? No, that would not make sense. So since I can't have any fraction shape numbers, I am not going to connect those dots. Congratulations, look what you've just done. You took this problem situation all the way back here. You took this and you have displayed this information. Look at this list. As a diagram of figures, then you created a table of values. You wrote algebraic expressions to explain verbal descriptions, then you created a graph. Everything you've just done are called multiple representations. Break that down. Multiple means more than one. Representations, ways to represent information. Absolutely fantastic job.